Hey everybody, how's it going? My name's Jeremy, one of the guys here at Flyin Miata, and today we are going to have a Facebook Live and talk to you folks about pistons. So this is a critical component of everything you enjoy, driving your car, making power, all the other things have to do with these things going like this. So here at Flyin Miata, for the last, 20 plus years, we have been creating and selling a custom designed piston that's made for us by Wiseco out of Ohio, American made. And over time, we've been refining the design. And so I just wanted to talk a little bit about that today, kind of how we got to where we are today. And this design has actually been, for the last 7-ish years has been pretty stable because we've gotten to just a really great spot, and it's an awesome piston that we're really happy with. So let's just talk a little bit about the history. If you have a Miata and you want to put a turbo on it, or you want to make a lot of high compression horsepower, the stock stuff is only good up to a point. And this is, a lot of you guys already know this. With your stock pistons, etc., we've always had really good luck with our turbo systems running up to about 10, 12 PSI, 250 or so wheel horse as far as long-term reliability. Once you start to exceed that in the NA and the NB cars, and you start to approach 300 and definitely beyond 300 wheel horsepower, you're going to start to break pistons and rods. And so you have to look at a forged engine. And so, there's lots of different components to that, your studs, your rods, and your valve train, and possibly most importantly, the pistons. So that's what we're going to focus on today. These days at Flyin Miata, we are selling a 9-to-1 compression 1mm overbore piston for the B6 and the BP. In years past, we've done lots of different things. We've had high compression pistons. We used to have a stroker kit that took the engine out to about 2 liters. Various other things that we've done in the past. And they were maybe successful in their time, but as time went on, at the moment, the thing that we are still offering to everyone are these beauties. So they used to be naked. Like when I first started working here in the early 2000s, these were just naked. So we'll start to talk a little bit about the kind of design. Over time, a couple of things we did is we added some coatings to them. The skirts of the pistons got a Xylan, you kind of call it a moly coating, but really it's a Xylan skirt coating. And that just helps really with break-in, because ultimately this is going to wear off a little bit from scuffing and from use when the piston's in operation, but it does kind of help with the initial break-in and kind of make things a little bit smoother, and also it makes the piston a little bit quieter. One of the really nice things about our forged pistons is with this design, when you start up an engine cold, when it's been built correctly with the correct overbore and the correct all those other things that the machinist would do, they're actually relatively quiet for a forged piston. And one of the reasons is this coating. Another reason that they're relatively quiet is the skirt taper. One of the things that we worked on to customize for us is to, when you look at the taper of the skirt, because the skirt is a little bit wider than the diameter of the head here, you've got a certain taper that has to do with how the metals expand, because aluminum expands more than steel, and the hyperelectric stock pistons are going to expand at a slower rate than these forged pistons. So a lot of times when you get a forged piston, it's actually cut a little bit loose in the bore because it expands a little bit more, and so it kind of rattles when it's cold. But with this taper and with this coating, we've made it so, relatively speaking, it's not as quiet as stock, but for a forged piston, it's actually pretty quiet. And that's one of the things that makes it just kind of a nice setup for even just a daily driver, is it's not just super duper noisy. With that, one quick little rabbit trail is to note that with any forged piston build that you have, whether it's ours or someone else, it's very, very important to make sure that the engine coolant, and especially the engine oil, which takes 2 to 3 times longer to come up to temperature than the coolant does, is fully up to temperature before you get on it, because this is going to expand just a little bit. And for oil life and engine longevity, just make sure that everything's fully up to temperature before you really start to hammer on the engine. Super important. So another thing we did is we had Wiseco do for us a ceramic-based crown coating. And in years past, this is kind of a slightly older one that I just kind of keep on my desk to show you guys today. But it's kind of this gray, typical ceramic color. The stuff that Wiseco doing now is actually kind of a gold-colored ceramic. And so if you were to get any of those new from us, it's going to have that gold top on it. But that's also going to help to protect the crown of the piston. If you do get some detonation for whatever reason, it's just going to be a little bit of an extra barrier because aluminum actually melts at a lower temperature than combustion. And the reason that pistons don't just melt when you're using them is because there's a thin layer of film, a thin film of fuel on the top of the piston. But when you get detonation, that can actually blow through that thin layer of fuel and expose the raw aluminum, and then sometimes you can get pitting in the aluminum because the combustion temperature is actually hotter than the melting point of aluminum. So having the ceramic crown on there helps to protect you against that because ceramic does not melt anywhere near the temperature of aluminum, and so it just makes it tougher. So it's basically made so this is an extremely tough piston. Also with the rings, we've always had Wiseco spec out their top of the line rings. It's the XX. So if it's an 84 millimeter, it'll be 84XX. And the valve pockets here, we have these spec'd out so they can accommodate +1 millimeter valves, because we're a really big believer in the +1 millimeter Inconel valves that we use. Miatas over the years have had a lot of issues with valve problems, and having those Inconel valves basically stops those problems dead in their tracks. So, we've got these valve pockets that can accommodate that. And then one final design change that came about a number of years ago, for the first, maybe this is maybe in the early, like 2010, 12, I'm going to guess somewhere in there. In the old days, the design was what was called a skirted design, where the skirt of the piston basically came most of all the way around. And it looked different, and the way that this down here was built was different. But as we started building higher and higher horsepower Miatas, once they started to get up in the 400 plus horsepower range, we actually started to see cracking in the skirts. And so we talked to Wiseco, and they said, oh, yeah, that's going to happen. We have this new strutted forging that we've been using. This is Wiseco talking. And, in the Subarus and the Mitsubishis that were, making really big power back a little bit before the Miatas guys got into really big power. And so let's try that. And so we actually switched over to what's called the strutted forging. You can see the skirt here is cut down to, a much more minimal setup. And then it's got, instead of having just the support all the way around the skirt, it's got this internal kind of almost like an I-beam or an H-beam type of a support. And these are much, much stronger. Wiseco told us at the time that, these are probably good for a 1200 horsepower engine, which is way more than a BP is ever going to create. And since we've went to this strutted forging, we've had zero issues related to horsepower. So, we've got this piston dialed in, and we're very happy with it. Size-wise, the pistons that we do for the B6 and the BP are 1 millimeter overbore. So on the B6, stock is 78 millimeters, we go 79. On the BP, stock is 83 millimeters, so we go 84. Early on, one of the things we did is we took a couple BP blocks, and we actually took a big bandsaw and we bisected them, and we wanted to look and see how much material is in the walls, so we could talk to some engineers and say, how much are we comfortable overboring these? And what we came up with was, typically 1 millimeter is where we were comfortable for the turbo cars. We did stretch that out to 1.5 millimeters on our strokers because we wanted to get up to, it ended up being 1995 cc with the extra bore and the extra stroke. So as close as we could to 2 liters. And we never had any issues with that all the years we were doing the stroker. For the naturally aspirated, we ended up going +2 millimeters because, it's obviously not going to be the cylinder pressure on a 180 horsepower naturally aspirated as there is on a 400 horsepower turbo car. So we went to 2 millimeters. And on all of those scenarios, we've never had any trouble. Even with, we had one particular customer that we've been friends with for a long time who's built, he built I think it was topped out at about 575 horse Miata, and this was back in the 2000s, early 2000s. He actually did crack his number 4 sleeve in his engine, running almost 600 wheel horsepower. Other than that, with all the folks that we've built engines for over the years, I don't remember hearing of anyone else who's doing this +1 millimeter or +1.5 having any problems with cracking skirts. So it works. We don't recommend going bigger because we know this works and this gets the job done. So let's see. Also, these pistons, when they come as a balanced set. So Wiseco, when they build these, they're going to, weigh them out and measure them, and you'll see that when you buy these pistons from Wiseco, you get a spec sheet that has all of your detailed specs, and one of those is going to be the weight of the pistons. And if I take 2 or 3 sets off the shelf, you can see in between the sets, the weights are maybe slightly different because they're actually, when they're building these, and then they're matching them up to try to get the weights just right. So that's also really nice. Let's see. Performance gains. This is a 9-to-1 piston for the turbos. The NA8s are 9-to-1. The 99 2000, the Mazda speeds are 9.5-to-1, and then the VVT engines I think are 10-2, I want to say. So as far as performance improvements, really the reason to go to a forged piston is because you're making a lot more horsepower. You know, you don't, a stock guy or a turbo guy, you're not doing it because you're looking to just drop in a piston and make more power that way. Yes, you can go to a higher compression piston and make more power if you also accompany that with a standalone ECU. However, as we've discussed in the past, there are reasons to do that, and we did used to sell high compression pistons. They don't really sell that well because there's not that many guys doing it because it's not good bang for the buck. You know, some guys want to do it for other reasons other than horsepower per dollar, and that's totally great. However, you know, most customers just on volume want to get best horsepower for the dollar, and a turbo kit's the way to go. So we stopped selling the high compression pistons just because honestly there's just not that much demand for them. Yes, you can do it. No, we don't currently offer those in our catalog, although we have in years past. To get the most out of these pistons, you're also going to want to upgrade your rods because bent and broken rods are definitely a thing when you also start turning up the horsepower in the Miata. We do have a number of knowledge bases in our customer support department that do talk about, and we can link to those in the comments after the video is posted. And those knowledge bases are going to give you kind of an overall idea of some of the things that you want to do in addition to the pistons to build a good, robust built engine. We're just going to focus on the pistons today, but suffice to say, at the very least, you're also going to want to add a set of forged rods, and we do keep the Carrillo rods in stock that we recommend matching with these lovely pistons. We did get a question about E85, and this is an interesting thing that I wanted to add. Can you go to a higher compression ratio on a turbo? Well, with a turbo setup, yes, you can go with higher compression and it's going to make the turbo a little more responsive. However, as you go higher compression, you're going to need to increase your octane in order to keep from detonation. And this 9-to-1, because this is the best for the most people, for the, you know, generally speaking with the turbo Miata on pump gas, this is the sweet spot, and that's why we've always been right here. We did get a question that said, with E85, can you go higher compression? Yes. You can go much higher compression. But the thing you want to remember is as you go higher compression, you're taking up combustion chamber volume. And there comes a point where even though you're going higher compression and you're getting a more responsive setup that the E85 octane can handle, you're actually reducing the amount of space in your combustion chamber that you can physically put air and fuel molecules. So there comes kind of a diminishing return point. Yeah, just because I can run 11-to-1 compression pistons with a turbo, if you're looking for high horsepower, it doesn't necessarily make sense because you just can't stuff as much air and fuel in there. So this is something that I've talked about with a lot of high horsepower guys in the past, even in, you know, the Subaru and Mitsubishi world where they've done a lot more testing on that than they have in the Miata world. And kind of a general ballpark consensus is if you're building an E85 turbo engine specifically, then you might want to look at going as an optimum rate. I think it was about 9.8-to-1 was kind of a sweet spot of having a little bit extra compression, but without handicapping your available combustion chamber space all that much. So kind of a rabbit trail, but that is an interesting thing because E85 is wonderful for turbo cars if you have access to it. Oh, let's see. What else can we talk about? One of the things that we have in our knowledge base is an engine assembly worksheet. When we were building engines here at FM, this is the process that we would go through to set the rings, to set the gaps, to set you know, the bearing clearances, all those other things, make sure you didn't miss any steps. So that's something that you can also access in our knowledge bases. But one other thing that I wanted to talk about having to do with the pistons is Squish. So when you deck your block and you have your piston at top dead center, you measure the difference between the deck height of the block and this top area of the piston here, because you also have to keep in mind at the top of your head gasket where your head surface is, because your head surface is going to be right above this flat. The distance from the top of the piston, top dead center, to where your head surface is called your squish. And for optimal even combustion across the face of the piston, the generally accepted place is that you want to have your squish between about 40 and 50 thousandths. Not more than 40, not less than 50. So that's where one thing to keep in mind is, when people call up and say, oh, I want to get an engine rebuild kit, I want to get the pistons, all these other things. And I say, well, there's an order of operations here. You need to go ahead and get your head and your block machined. I mean, your head kind of is what it is, but the block, because depending on where your block is decked, you're going to have to get your pistons and you're going to have to measure it. You're going to have to see where your piston sets in relationship to the deck of your block so that you can get the correct head gasket thickness so that you can get your squish correct. So something to keep in mind is when you're building an engine, you don't just want to go order all the parts. There is actually an order of operations so that you can build it correctly and get things right the first time. And the factory Mazda head gasket, which we use for most applications, is 32 thousandths for the BP 1.8 MLS head gasket. And then we also offered a Cometic head gasket that was 40 thousandths. And between those two, we were almost always able to get customers in that range of between 40 and 50 thousand squish. So that's a fairly important thing to keep in mind as well. Another thing actually we get questions about is obviously the BP and B6 blocks have oil squirters underneath that from the factory setup, they've got this little banjo bolt with a squirter that aims up here and points oil up to cool the bottom of the piston. With the old school skirted design, we were able to reuse that by slightly bending the nozzle, although there was more than once where we took off an oil pan and found the squirter nozzle laying in the bottom of the oil pan. With this strutted design, it's just not compatible and it just doesn't work. And so we actually remove the squirter. We take a bolt, we have to shorten it to about a 10 millimeter or so under head length, get a copper crush washer and seal the hole, torque that thing down with a copper crush washer to seal the hole so that you don't lose oil pressure. And people always ask, oh my God, it's gonna explode. Well, we've been doing it that way for a long time. And not only does it not actually cause any problems, but it actually also reduces oil consumption, because one thing that we found is with the squirters, specifically with the forged pistons, because it's just bathing the bottom of the piston, and the pistons are a little skinnier when they're cold, it significantly reduced the oil consumption. So when we went to these, we were starting to see forged engines that were not only quieter, but also had much lower oil consumption, because forged built engines generally do have a little bit more oil consumption than you're going to see, and that really improved it. So not only was it a non-issue pragmatically as far as the health of the built engine, but it actually was better as far as not burning oil and causing all those other things that come with burning oil. So that's an important thing to think about as well. One last thing, this is a pretty neat little tool that I wanted to show you guys that Wiseco has. And if you're out there building an engine, when you are, the old school way, you've got this kind of ring that kind of goes around here and compresses, and you get your piston rings in here, you set all the gaps, and then you compress the piston rings, and then you kind of tap it down, and it's kind of a one-size-fits-all tool. Wiseco makes this really slick tool that's specific to the diameter of whatever piston you have, but it's a taper. So you can put in your rings, drop the thing in here, and as this thing goes down, because it's tapered, it just automatically compresses your rings into place by the taper. You can get your skirt right down in the bore, get this right down, and just tap this guy right down in. Super, super duper slick. So if you're building an engine, this is a really nice thing to have as this extra little tool for installing cleanly and getting your rings set very nicely, without worrying about, chipping a ring on the edge of the block when you're tapping it with a hammer and the thing pops out and whacks the top of the block. So really, that's the history of our FM Wiseco pistons. A couple other just random notes. Remember, your head gasket wants to follow your head if you're doing swaps between different ear heads and different ear blocks. And gosh, what else? Pistons aren't, they're complicated, but they're not super complicated. They're just one piece of the awesome, let's make more power in our Miata puzzles. So let's see if we have any questions. Looks like we may have something coming in that Mike's going to let me know.
So if you wanted to build the smoothest running engine, would you still consider, and let's just say just naturally aspirated versus turbo for now, would you still consider upgrading rods and pistons if your ideal engine is the smoothest running engine?
The question is, if you want to build the smoothest running engine, do you still want to consider upgrading your rods and pistons? Well, if your number one concern is just the engine running smooth, then the number one thing you want to upgrade is to an ATI damper. It makes your engine run like a sewing machine. Having everything balanced is also going to help that and be important. So, you know, a balanced set of pistons, balanced set of rods, and also very importantly, balancing the crankshaft. Another little rabbit hole thing, we do not recommend knife ending the crankshaft, and there's a lot of backstory on that, but suffice to say, we just don't recommend knife ending it, but balancing it, absolutely. So if you want to build the smoothest running engine, balancing all of your rotating components and putting on an ATI damper, possibly that's the most important thing of getting a super smooth running engine. And you know, generally speaking, BPs and B6s aren't like the smoothest running engine out there compared to some of the other things. You know, some of the really high revving engines on the market. But if you do those things, you can actually make them surprisingly smooth. There's been a number of them that we've built here. I remember driving home in a build that I was breaking in, because part of what I used to do is every engine that we would build here, we would install it, and then I was responsible for the break-in and the calibration of the ECU. And so I would, you know, be spending lots of time driving all the customers' cars and doing those things. I remember, you know, doing some break-in, and then we were doing some higher RPM stuff. After the engine was broken in and we were starting to give it the beans a little bit, I remember driving down this hill that we have outside going home from work. And there's this hill where you just kind of leave it in gear and then, you know, kind of engine brake down the hill. And this thing was doing like 7,000 RPM. And I looked down like, oh my gosh, you know, it was sewing machine smooth. And it had all those things on it. And I was like, oh, that's one of the first times I really said, oh my gosh, this ATI damper is amazing. Like, this thing is just cruising at 7,000 RPM and it's might as well be 2. It's so smooth. It was really amazing. So that's where I would focus for just a pure smooth running engine. The forged aspect of these things isn't really going to make a big difference there. So, okay. Well, remember, we have our knowledge base. If you guys have more questions, we also have our wonderful customer service team. Please be patient with them because they're so wonderful that they are very well utilized. And that's really about all I had for Pistons today. So thank you very much. We appreciate you coming to check this out. This will be posted. If you have any questions, you can leave them in the comments, and we will do our best to answer further questions as time allows. So have a great day, and everybody take care. See you next time. Bye.